Hello everyone, in this video we're going to look at how can we measure the relationship between two variables. Okay, at this point we already learned how you are able to summarize in the sample size, right? We talk about that you always need a statistic to measure the central location. You always need to talk about the statistic to measure the variability, and we kind of talk a little bit about the shape of distribution. We're going to add the statistics at the end of this chapter, but those are the three very important statistics you need to discuss when somebody asks, hey, summarize the sample for us. However, here we are exploring another aspect of the numerical descriptive statistic, that is finding the relationship. So in the previous chapter, what we learned that in terms of data visualization, we can use a scatter plot if both variables are quantitative data. If at least one of them are categorical data, and we're going to use cross-tabulation to find relationship. And here, when we look at numeric descriptive statistics, we focus on the quantitative data. So basically, what we're going to look at here, the statistic, will be the supplementary statistic you can use to attach on your scatter plot. So it will make your scatter plot's result more rigorous. Okay, so in the scatter plot, we are able to identify positive and negative relationship. And here we're going to learn two statistics. So one of the statistics actually are not only able to allow us to identify positive and negative relationship, but it further show us the strength. So we will be able to be more robustly to identify whether the strength of the relationship between X and Y are strong or weak. Okay, first let's look at the first statistic called the covariance. Okay, so for the covariance, I'm listed two formula here. So when you work on our homework assignment, we actually going to focus on using Excel to calculate covariance versus using the manual way to do the calculation, because as you can see on the formula, it turned to be very complicated. However, I still want to show you this formula because as you notice that similar as our standard deviation, our variance, for covariance, the data's population covariance are different from sample covariance because the denominator n versus n minus 1. So this is the same reason as I explained it for variance. So for the population variance, since we are able to observe our sample mean, and we no longer we don't estimate it, so we are not losing the degree of freedom. However, for the sample covariance, it's a different story. So the X bar and the Y bar, they all rely on us using the sample data to estimate it. So therefore, we already lose 1 degree of freedom, and we need to consider that. So therefore, the denominator become the sample size minus 1. So that also means when we look at Excel, I'm introducing two separate Excel formula for covariance, one for population, the other for sample. So therefore, pay special attention when you work on the homework. Is the question asks you for the population covariance or sample covariance? So without specific note, we consider the data we work on in this class is the sample data. Okay, so we're going to use the sample formula more often. So for the covariance, covariance can be any real number, negative and a positive. So there are no lower limit or upper limit. So therefore, when you look at the covariance, you only can understand whether the relationship is a positive or negative. So I think at this point, you might ask, hey, Dr. J, sounds like the covariance gave us exactly the same information as scatter plot. The answer is you are right. So similar as the scatter plot, the covariance only can tell us the direction of the relationship, but it cannot tell us the strength. So therefore, the statistician make an improvement to create another statistic. So in the next statistic I will introduce to you, you will notice that statistic not only can tell the strength of the direction of the relationship, but also the strength. Sorry, I want to make one correction. So the covariance can be any positive number, any real numbers. Okay, so here we go, correlation coefficient. So this is the more popular use to measure the relationship between two variables. I rarely see people use covariance. Okay, so the reason is that for the correlation coefficient, you are able to identify the direction of the relationship, but also the strength. For the covariance, you only can detect whether it's a positive or negative relationship. That's it. So therefore, correlation coefficient are able to tell you more information. Why not just using this? So therefore, for our class, we are focusing on the correlation coefficient, and we're also going to work on some calculation as well. So let's look at how correlation coefficient being calculated. So correlation coefficient for the population, we call it a rho. So it's not P, okay? So it's a rho, so it's a Greek letter. And when we're dealing with the sample correlation coefficient, we just use R. Okay, so the numerator is our numerator and the denominator are very different. So the numerator sigma xy. So the sigma xy is what we just saw, is our covariance. So basically the numerator is the covariance between x and y, okay? And the denominator are two separate standard deviation. It's x standard deviation times y standard deviation. Okay, so the numerator is covariance and the denominator is the standard deviation of x times the standard deviation of y variable. Okay, so by structure, this ratio give us called the correlation coefficient. Okay, correlation coefficient. And what is the characteristic of the correlation coefficient? So correlation coefficient has to be between -1 to +1. So it's really different from covariance, can be any real number, right? And so when the value are close to 0, and we consider there no linear relationship between x and y. So when the R of the correlation coefficient close to +1, we consider it as a strong positive relationship. When the correlation coefficient close to -1, we consider it as a strong negative relationship. So it's bonded between -1 to +1. And so what I usually do is if the value is larger than positive 0.5, okay, let me draw this line so you will have understanding. So this is the scale, right? So this is from -1 to +1. And this is the 0. And here to 0.5, -0.5, and the +0.5. Okay, so this is no relationship. And then anything between 0 to 1, so this is a positive relationship. And then this side will be negative. And then anything between -5 to -0.5 to +0.5 is a weak relationship. And then between 0.5 to 1, that will be strong. And this side also strong. So how you use this scale to help you interpreting the R, right, the correlation coefficient. So let's see, I got this number 0.75, okay. So 0.75, first of all, it's positive value, therefore it's a positive relationship, but also we can tell the strength, right? So 0.75 is belonging to this region, so therefore it's a strong positive relationship. Okay, that is how you are interpreting the R, so the correlation coefficient, and you can apply this scale to always guide you to interpreting the result. Okay, so now if you look at the following, and the 0.9, and then so 0.5, so it's approximately 2.5, but actually if you keep more than 3 decimal places, it's 0.499. So the first one is a positive strong relationship. The second one is weak strong relationship, and the last one here is no relationship. And then the one under the first one under the second row is a strong negative relationship. The second one is a weak negative relationship. The last one is no relationship. Okay, so that is how related your correlation coefficient with the scatter plot. Like I said, the scatter plot, you definitely can tell positive relationship, negative relationship, but having the correlation coefficient with strength will make your analysis more robust. So what I do in the corporate usually is once we're demonstrating the scatter plot, we always try to attach the R into our diagram as well, so that the chart will be open to exactly who have no statistics background to look at the trend line, or for the other analysts who are able to see this more robust result to say, hey, I see this is strong relationship, right? Okay, now let's look at question together. And at this one, we're going to look at the computer skill where we actually learn how to use Excel to calculate the correlation coefficient very efficiently. But here we just use hand, apply the formula we just saw to calculate the R statistics. Okay, so closing price of 2 stocks are recorded for 50 trading days. The sample standard deviation of stock X is 4.638, and the sample standard deviation for stock Y is 9.084. The sample covariance is -36.11. calculate the sample correlation coefficient, and describe the relationship between the price of these two stocks. Okay, so let's look at it on my whiteboard together. Okay, so now let's look at on this whiteboard. Okay, oops. Okay, so first of all, we know that the sigma, the first is the stock X, so that's the sigma X, or you can see the odd, so this is the sample, so everything here we see is going to be the sample. Okay, so make sure my notation are consistent. So Sx is equal to 4.638, and Sy is equal to 9.084. And then the last one is my covariance, Sxy equal to negative 36.111. And we learned the correlation coefficient is equal to Sxy divided by Sx times Sy, right? So we just literally apply this formula. My numerator will be negative 36.111 divided by 4.638 times 9.084, and then we will calculate 36.111 divided by, let me use my calculator. Okay, 4.638 times 9.084. Okay, so that will give me 42.1316. Then I'm going to use 36.11. Make sure you know it's negative. And then divide by 42.1316. So that will give me the value of negative 0.8571. Okay, that is the answer for A. Calculate the sample correlation coefficient. Now we need to describing the relationship between these two stocks. So again, we need to go back to look at the scale I just showed you, right? So first of all, it's a negative value, so therefore it's a negative relationship. Second, that value, negative 0.8571, is between this region, right? Negative 1 to negative 0.5. So therefore it's a strong, right? So it's a strong negative relationship. So therefore for B here, okay, would be strong negative relationship. Okay, so this might be the answer just for the math major student, right? So we are business student. We should not stop at here. So what does this strong negative relationship actually mean in this sense, right? So that means if X stock price goes up, Y stock price will goes down, right? So remember, the negative relationship doesn't mean they always go down together. It means they go opposite direction, just like your demand curve. Think about your demand, right? So that means if the X stock price go up, Y stock price will definitely go down, or the X stock price go down and Y stock price will go up. So now you finish the interpretation, okay? So you cannot just stop at, hey, strong negative relationship. That's for the math major student. So you are a business student, you need to go further to derive the interpretation that make business sense, right? So I hope you are striving this kind of interpretation versus just stop at strong negative relationship. Okay, so that is the end of this video. And in our next video, and you're gonna what you were focusing on is gonna be the computer skill to learn how to use the Excel to calculate the covariance and the correlation coefficient. If I give you a data set versus just give you the standard deviation and the covariance value. Okay.